Okay, you will think about again if you want to do some applause after my talk. But thanks for the applause in the beginning, so I'm not sure if you will continue that on the end. Anyway, so I'm really glad being here. So welcome everybody. Thank you for inviting me. And I will talk a little bit about my conception, where we are, where we're going, and how we're going to prepare for that. It's a code-free talk, sorry about that. So in the evening, I will talk about, and at the meetup, I will talk about a little bit more technical stuff. This is more like how to set up. And the biggest problem I probably have is to put all that into the 60 minutes I've got, because it's quite a lot of stuff. And yeah, I hope I get it done and convenient. It's still in the morning, you had your coffee, you're still ready to get something to absorb some stuff, so be prepared for drinking from the fire hose. Sorry about that. Anyway, my name is UweFriedrichsen, and I'm not going to bore you with a lot of my history and blah, blah, blah. I'm working as a CTO at Codecentric, and part of that job is looking into the future, seeing what's going on, how to prepare for that, and so on. And coming from that role, basically I created this stuff. The rest of it, yeah, the only interesting stuff maybe inside there is the SlideShare account where I'm going to share the slides afterwards if you want to look up some stuff that I've talked about. As I said before, it's a lot of material and it's maybe a little bit hard to get your mind wrapped around all that stuff in just 1 hour. At least it took me some years to get my head wrapped around that. So yeah, you're faster than I am, but 1 hour is probably still a little bit hard. So maybe you want to look up some things of the stuff later on after I finish this talk and you recovered from that. But okay, a bit of motivation. Let's get it started. So, I mean, IT today, it's a madhouse, isn't it? So, and they're all going mad. And so, do you also feel a little bit like it's really hard to grasp all that stuff and pieces, and that you still get less and less time to understand all the new stuff? I mean, if you're doing normal technology, every 2 months some new stuff comes around and here's the new hype and everything. If you're doing JavaScript, it's every 2 days, and yeah, but it's lots and lots and lots of new stuff to pick up, and all that agile stuff, which had the promise to make it better. Isn't that like, okay, before your boss came to you every 2 months and told you, hey, you're not productive enough, even if you were working 12 hours a day, and now it's coming around every 2 days, and it's even worse to pick new stuff up because you're agile now, and everybody is just, hey, you must increase your velocity, and all. And by running around saying, yeah, but I've got the impression that something's wrong, something's changing out there, and I don't find the time to pick that up, and wasting my time here in that crazy rat race, and yeah, and then these articles are around, so, oh, AI will take over our jobs, and do I need to change something? Which was the wrong, let's try that one, yeah, that's better. And all this other disruptive stuff, and yeah, so you stand there. Should I rearrange, or should I refocus a bit, or not? Am I still on the right track, or am I doing the wrong things? But I don't know, because what are the right things? So I've seen quite a lot of people that feel a little bit more like that, so drowning in all that stuff and confusion. Or, yeah, just go nuts, which is the better alternative, by the way. So you feel better emotionally, at least, if you take that direction. But if you feel like that, or at least a little bit like that, then it might be time for a little bit of a hitchhiker's guide to figure out what's going on. If you don't feel like that at all, you can check your emails right now and then figure out when I'm done and then come back to the session. Anyway, so what I'm going to talk about, basically in the reminder of the session, is 4 things. The first thing is understanding where we are, so where we came from, where we are. Then the second thing is talking a bit about the trends that I see at the moment. Third thing is how to use that information to figure out where you are standing and where you want to go and how to get there. And the last thing is a few recommendations how to stay ahead of the curve. That's basically it. But as I warned you, it's a lot of stuff. But before I start with that, it's a Hitchhiker's Guide, so don't panic. And you might think, I see the world a little bit differently than Uwe does. And just to be clear about that, that's perfectly fine. The only thing that I can offer to you is my point of view based on my experiences and what I see around there. I think what I try to give you is not the universal truths about IT. I don't know the universal truths of IT. I can offer you a viewpoint and I can offer you some food for thought. And that's what I try to do in the rest of the talk. Use it, make up your own mind, find your own answers to the questions you have and so on. And maybe there are some ideas in here which help you to find the right way. That's everything I can offer to you, so just to be honest. But let's start. Understanding IT. Where are we? And where did we come from? Actually, to understand where we are, we have to understand where we come from. And it's a complex thing. It's a complex beast, IT today. So let's try a few different viewpoints. Starting with a non-IT viewpoint, because that's crucial to understand what we are serving most of the time. It's a market evolution. So most often, IT supports some kind of business, and we have to understand that business in order to understand how we need to respond to that in IT. So let's start with the market evolution. And if you talk about market evolution, what you see quite often is this kind of curve. So anybody has seen that before? Oh, a few people, yeah. And okay, brief explanation for the rest of you. Bar-step curve. I took that from the Beta Codex network, but there are other places where you can find that. And it basically talks about market evolution. Let's briefly start with the pre-industrial era. I mean, IT wasn't relevant back there, but we will still talk about that for a second because history is repeating inside IT, and therefore it's quite interesting to understand that one. Pre-industrial era. When you wanted to have something back then in the pre-industrial era, so late 19th century, you went to a craftsman and said, yeah, I want to have this and that, and negotiate a little bit and agreed about that. And if you got your conversation right, then the craftsman usually said, yeah, okay, come back in a week or something like that. And then you got what you ordered. And it was exactly what you wanted to have. It was great. It was usually high craft and all that stuff. And yeah, which was a cool thing. I mean, the key to success back then for the craftsman was mastery. Knowing the business, knowing to talk to people. Yeah, craftsmanship, so sort of like that, isn't it? Yeah. There were only two drawbacks in there. The first thing was, it was very expensive. Very few people were able to afford that stuff. And the second thing was, it didn't scale. So if you said, I want to have one table, that wasn't a problem. But if you went to the same crowd and said, I want to have 100 tables, that, whoa. No, step back, 100 tables is quite a lot. And so it didn't scale very well. But we know this problem was solved. Standardization, Henry Ford, Frederick Winslow Taylor said, yeah, let's standardize the product a little bit. You know the famous quote probably from Henry Ford, you can order the Ford T in any color you like as long as the color is black. So standardization. And then setting up that production process, so splitting it up into parts, into chunks, creating that assembly line, and then creating that product. And by doing that, they were able to do two things. The first thing is they were able to create a lot more items, so scale up production a lot. And the second thing was very interesting. Also, they were able to offer that stuff at a lot lower price. And if you have a non-saturated market and you're able to reduce your price by 50%, you're able to address about or get about 10 up to 50 times the number of customers you had. So, and the effect of that was there was a really high demand and a not so high supply, even though they were scaling up their production. And this gives you a producer-driven market, a very slow market, which is a sluggish market, where the producer, the supplier, basically dictates what's going to be produced, how long it takes, and everything like that. It's a slow market. You can do whatever you want. I mean, as long as you're not doing it completely wrong, whatever you produce is more or less guaranteed to be sold. And so these kinds of markets, cost efficiency is key. So how much can you produce for €1, for $1, for whatever? That's cost-efficient markets. And this was quite predominant for a lot of years in the last century, mostly for the whole last century. But then things changed a little bit. Globalization, internet business, and all that stuff, they were game changers. There were more game changers in there, but these were the most dominant ones. So you had more and more producers, suppliers per customer, and slowly but surely, for the different branches at different times, this relation between demand and supply flipped around. So you had a lot higher supply than you had demand after a while. And this changes the market dramatically, because right now consumers are no longer just going to buy because you deliver, but they're going for the supplier who meets their needs the best. For instance, who has ever ordered at Amazon? Yeah, I mean, it's an easy question, isn't it? And I'm quite sure nobody of you has ever ordered at Amazon because they were the cheapest, because they are not the cheapest, but they meet your demands better. It might be okay if you need to return something, it simply works, or whatever it is, or a lot of reasons could be there, or we don't need to discuss that. We can do that in the coffee break, but meeting their demands. And so the market is driven by those who meet the demands of the customers best. So the new key to success is no longer to produce as cheap as possible, but to listen to your market, to your consumers, and adapt to their needs and their demands as fast as possible. So that's a very different paradigm. And so to wrap that up, we have 3 different paradigms, and especially the industrial and post-industrial are interesting. Cost efficiency and scalability on the one hand, slow change rates on the other hand, how fast can you get an idea out into the market, and how flexible are you? So this flexibility, which is a very different paradigm, a very different kind of business you're going to support, either if you're an industrial or post-industrial market. Okay, getting back to IT, viewpoint number 2. So we know what kind of business we're going to support. Now, how did IT evolve? And let's take a little curve. Here the time, here the degree of business support of IT, so how holistically we support our business. And I think it's a curve like that. It started back in the 50s, late 50s, so transistors, mainframes made mainframes attractive for commercial businesses, and so companies started to use computers over there, and yeah, I mean, these computers didn't have a lot of computing power. I mean, each smartphone you have probably has more than 1,000 times the computing power than those mainframes had. Still, it was possible back then to create a few reports here or there, or very little analysis of stuff, and so on. And that was great, because, remember, pocket calculators became available over here. So if you were forced from a business side to create a report every day, it took you paper and pen and maybe a slide ruler for the multiplication, but that's it. And doing that every day is not a lot of fun. And so a computer was great. And said, yeah, that's cool, we want to have more of that. The problem is, and that led to the software crisis, is back then, IT was in the pre-industrial age. So whenever you got hold of one of these software engineers, they had different names back then, but however, these kinds of guys who wrote software, then it was cool, saying, yeah, I want to have this and that and blah, blah, blah. Like you talked with a craftsman in the late 19th century, and they said, yeah, I understand that, and yeah, come back in a week or two and something, and you got that, and it was exactly what you want to have, but it didn't scale. There were too few of them. And this created a software crisis, basically. So a lot higher demand than supply. But IT folks went stupid and said, we have to respond to that. Scaling software production in a cost-efficient way. Hey, we had that before. Let's take the ideas, the industrial ideas of Henry Ford and Frederick Winslow Taylor and apply them to software development. So let's split up our software development process, business analysis, requirements engineer, the architect, the designer, the decoder, the tester, and all that stuff down into the down to production, and create that virtual assembly line. We call that software development process. Yeah, and it worked nicely. So it wasn't bad. It was a great idea back then, and worked quite well. Problem was, the more we were able to deliver, the higher demand became. And so we were stuck in this kind of crisis for about, 20 years. And after 20 years, said, we don't look very well in IT if we are stuck in a crisis for more than 20 years. So let's call that crisis ended. Seems to be the normal state. So crisis never ended, but okay, we officially ended it. It was ended by definition. But we're still in some kind of crisis these days. But it went on then afterwards. So personal computer networking came up, and we were able no longer only to support some kind of business functions, but also more business processes. So, and business processes are closer to the business, and business are human-driven, and this is always complex in terms of system theory. So it became a different domain that we are starting to support. And Moore's law did its job, so computers became more and more powerful every year, and the internet came up. You know the effects of that. And mobile devices later on. And these days, IT basically is the nervous system of every non-trivial business. So we support them holistically. Everything we do on the business side is supported by IT in some way or the other. Which not only means that and it has several effects basically, because the one effect most companies understood, so switch off IT, we've got a problem. But the other effect most companies didn't understand is we cannot change anything on the business side without touching IT. Because IT, meanwhile, is holistically, it's the DNA of the business. Everything the business consists of is coded into IT. So it's necessary. And if I want to introduce a new product, if I want to change a process, if I want to add a feature, I have to touch IT. We rent a call center over in India. Yeah, but how are we going to deliver the information to you and you from the IT in between? IT everywhere. Okay. And IoT, we have no idea. And so basically, bottom line is IT changed a lot over the decades. But what else to figure out here? Point is, but we still try to control IT these days with the means we figured out about 50 years ago, which doesn't work too well quite often. And if you remember that curve and this line, the same time, when the line in IT went up to complex, also the markets changed, which gives you another dimension. The business we support today is a very different one from the business that we supported when we set up the original ideas of software engineering. I mean, software engineering evolved over time, but the basic concepts are still the same ones that we started up in the late 60s. So if we look at IT these days, role of IT, basically 4 roles that I see. The first one is the nervous system that we talked about. The second one using new disruptive technologies. We will talk about a few ones in a minute. Supporting new kinds of business models like cloud, like big data, like mobile, and so on. And IoT, we have no idea what's going on, and. And so enabling new kinds of business models. So we are enablers with these kinds of technologies. On the other hand, we have to know how to handle those technologies. And then this digitization thing, which nobody really knows what it is, but basically IT becoming an integral part of a business offering. It's part of the business model. And the last one is communicating with your customers, figuring out what they want to have. Communication medium these days. Okay, so we understood IT. Maybe two more viewpoints, short ones, for wrapping up the picture. Technology evolution. So there were quite a lot of disruptive technology evolutions over time, which changed the way how we do IT. And it always took us some years to pick those ideas up. I mean, it started on the hardware side. So transistor enabling mainframes, then going from mainframes over multitasking to in Unix to server-based systems, which was a quite different paradigm than the personal computer, and then the wearable personal computer, so that we were able to take the personal computer with us. And also the business people were able to take them with us. Yeah. Basically, it stopped there. Then if we look at the programming model, it started with assembly language, and then we went to the high-level languages, which was about 1960, 99, end 50s, 60, then standard software, which created a very different paradigm for software development, because we are no longer developing everything ourselves from scratch, but we were starting to customize existing software in some way. So think about SAP and the whole industry which evolved around that, and also and open source democratization of software development, reducing the vertical integration depth, so we didn't have to implement everything anymore. I mean, I remember still having to implement a string class for every C++ project in the early 90s. I never want to do that again. I also don't want to implement an HTTP server on my own anymore, or something like that. So, by the way, I still have see all these nice discussions. Oh, this is a better language. This language is going to change everything. So you have to learn Scala, you have to learn Clojure, you have to go for Rust, for Go, for you name it. Hey, folks, this disruption happened 60 years ago. It's gone. It's not a game changer anymore. I mean, it's perfectly fine if you have your favorite language. Have it. But don't make a religious war out of that. Just my point of view. I also have my own favorites. That's okay. But it's a favorite, so what? And then connectivity, starting with local networks, internet, World Wide Web, modems, big game changer, Wi-Fi and mobile networks, which basically gave rise to smartphones and tablets, which were also big game changers and gave rise to a new whole kind of applications that we started to implement. And it also was a big game changer in the way that we no longer had to go to the internet, to computing capabilities worldwide. The computing capabilities worldwide always walk with us. It's a big change, basically, and it also affected a lot the way that of software development. And the last one that most of us still have to understand and to digest here is cloud and what it enabled, software as a service and backend as a service, managed services, serverless right now, which people need to pick up the idea and the big data concept, which were enabled by that. And then, on the other hand, from the industrial computing, that side, which starts to merge into business software development, so getting closer to each other. I mean, they did some stuff we never hardly recognized for the last 30 years, but right now they're getting closer back to us. So it's quite a lot of stuff which happened there. And this also affected the way we were programming some way. I mean, it all starts with do it yourself, program everything from scratch. Yeah, we like that, that's fun, isn't it? But basically, this evolved into, it's a simplified model, into 4 types of program models. So embedded computing, as I said, we ignored that for 40 years or something like that, basically. We had this high performance computing, so these, what we see then, these top 500 benchmarks and so on. Most of us are not doing that. So massive parallel computers and so on. Most of us are working in the middle part. So standard software customization, okay, some of you are also implementing standard software, which is more like the one above, which is then using frameworks, libraries, and so on for our support, not doing everything on your own. And back from that one, next one, I see 2 general trends. The one is going this enterprise software development with this Cormorant, SOA, and Java Enterprise and .NET and so on, what evolved from then. And the other side was more the web applications, so the Perl, PHP community and so on, always thinking in terms of web applications. So most of the Rastafarians, they lived up there in the upper side, not in the lower side. The lower side was the XML guys, basically. And then, yeah, I'm not sure how these things influence each other. I mean, high-performance computing sort of went into cloud native, and then we had this microservices. I don't think that microservices were evolution from the enterprise framework. I mean, I see a lot of people say, yeah, I'm using Spring Boot, and therefore I'm doing microservices, but basically they're doing nothing but implementing a new WAR file in a different fashion, in a different deployment model, but from the core conceptual model, it's a WAR file, what they're developing. And so I implemented some enterprise software, piece of enterprise software where I don't care about the environment and everything around that. And yeah, it's somehow HTTP enabled. Different story. I think it will blend together in the serverless community when this really is going to take off, which it's currently going. And yeah, we have the IoT over there. Different paradigms of programming, and very important to understand local and distributed computing paradigm, because world today mostly is distributed, and 98% plus of the developers I see still program as if they were programming in a local environment, which gives you brittle applications at runtime. What a pity. We could add some complementing viewpoints like the Gneiffein model, or however that's pronounced. It's a Galish word. I'm not sure how's the right one. And about simple, complicated, complex, and chaotic, we could use Wardley maps to analyze that very interesting concept, which helps you to figure out when to go from self-made to, so from make to buy, making the decision at the right time, figuring out if you're still having things that you're doing on your own, which you should better buy right now, or how to procure these kind of services, and how to set up your teams. I like the metaphor of the pioneer settlers and town planners, different kinds of people with different kind of mental models, which feel better in some different environments. I think I don't need to explain these kinds of pioneer settlers. It's quite obvious what they mean. And we had some other kind of ways how we could look at that. But that should be enough for the moment. I mean, it's confusing enough, isn't it? So that's where we are right now in IT. Wow. And now we still have to add, wow, where are we going? So, yeah, the trends. Where are we going? That's a bet on the future. Here's my bet. So if you have a different bet, that's perfectly fine, again. So I see 2 meta trends. The first one is digitization, whatever. I mean, it's a teenager sex of IT at the moment, or of the whole business. So, I mean, you know the teenager sex metaphor, like, yeah, nobody knows what it is, but everybody talks about it and everyone wants to be part of it, but yeah. So, but I still think it's very important. I mean, in IT, it does make a lot of sense because we are digital for 80 years now or something like that. But for other branches, it makes sense in some way. And basically, for me, digitization, use a different term, digital product development, whatever, means IT becomes an integral part of your business offering. So it's in there, it's part of it. It started with e-commerce in the late 90s of the last century, and it evolved over there from then. And but what most people don't figure out, that it becomes a real game changer for the industries, because that's something we just start to see at the moment, and most companies are having a hard time to understand that. As soon as your digital offering becomes successful, you offer that in some kind of API. And this API can be consumed in different ways. So business meshes, basically. And what's going to happen is, from a producer-defined API or offering, you go up the level to a consumer need-driven offering. So, very simple example. I have a heating at home. It's not a digital, so it's not a digitization example, but I have a heating at home. I don't care about my heating. I don't care about service contracts. I don't care about my energy supplier. I don't care about anything of that. My personal need is, if cold outside, warm inside, period. Everything else I don't care about. And if there would be anybody out there who would give me a decent offering, say, for a monthly fee of that, I offer you, if cold outside, warm inside. I would buy that. Take care about everything. If you need an insurance for covering or hedging your risk, I don't give anything. And so I don't care, basically. So I just care about it. And that's this idea of going away from domain-driven, so domain-driven in terms of here business domain, and producer-driven offerings to consumer need-driven offerings by combining all these kinds of offerings. This creates new business models that we don't even know about right now. And this has some consequences. The first one is uncertainty. I mean, post-industrial markets are uncertain anyway, because you always have to adapt to the customer needs and have to figure out what's going on. And is what I'm going to offer, is that anything that my customers want to buy? I mean, I only know that if customers are buying that. There's nothing anymore left over to predict that up front. So all the business case calculations that you see these days, most of the time you can simply throw away and ignore them, because it's just wild guesses. I can also tumble dice, and it's more accurate usually. So, and we have to respond to that, to this uncertainty, because if I go outside my own business domain where I come from, I know even less what's going to happen. And of course, we have to be part of the game. We have to offer all that stuff in kinds of APIs or even offering platforms. Most people underestimate what platform really means, so on. And we still have to stick with some persistent requirements in that new context, like the poor connectivity. Welcome to Germany. We're living on the edge, so due to the edge connectivity we have in most areas of our country, and accessibility, rethinking, and all that stuff, developer experience, not only user experience on the interface, but also on the API level, because nobody is going to use your API if it sucks, and all that stuff. And then we have a second meta trend, which is customer expectations. So customers these days expect great user experience. Read a user manual, go away. Help pages, no, it must be obvious what's going on there, and it has to respond fast. And it has to work on the devices I use and not what you're going to offer. And downtime, scheduled maintenance, go away. I want to use it right now, and I expect it to be up. And if it's not up, I go to your competitor, period. And security, built in, at least privacy. For the rest, very diverse requirements. So there's the one people who say, I want to use my password 1, 2, 3, 4, 5, 6, like I use for every other thing. And the other ones say, no two-factor authentication, go away, and all that stuff. So, and you have to adapt to all that, those things. And also inside companies, revolutions just just before, standing before the door. I mean, the times when you were able to say, it just took us 2 years to create an application with nice Oracle Forms windows, 50 fields, and we start up with a lot of these constraints, and you will never figure out how to fill out these fields, that it is going to accept your whatever you entered, and then we deleted all the constraints. Now you will never figure out how to fill out those fields in a way that you're not going to corrupt the data on the database. Days are gone. And this results in about 5 trends I see. The first one is we need to move fast. Actually, that's what DevOps in the core is about. How fast can I get out an idea to the customers, to get feedback from the customer, because I have to tackle uncertainty. And tackling uncertainty means inspect and adapt, build, measure, learn, blah, 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 blah. All these ideas. Because my biggest problem right now is to figure out where are the dead ends, where are the idle performances, where are the value-reducing performances, and cut those investments off. That's the way of saving money these days in a fast-moving market. It's not producing as cost-efficient as possible, but figuring out those as soon as possible and cut them off rigorously. That's really a big paradigm shift, and that's what DevOps, by the way, is about. Second one is we see a shift to the front ends. I mean, we all remember these days, oh, go away, you HTML juggler. Here's the people who do real important stuff. We are the backend developers, and we develop whatever language and so on. And we have these big application servers and all that stuff, which tells you I'm serious, I'm important. It's gone. These JavaScript fiddlers, they're ruling the world these days. It is. So battle for the customers gets decided in the front end. Backend just needs to support it, period. So UX, user interface, user experience, user interface become key differentiators. And on all levels of user interfaces, including developer interfaces, APIs. So developer experience becomes more crucial these days. A third one is then this response to backend as commodity, cloud native, serverless. We really need to reduce our vertical integration depth in order to get rid of all those things which make us slow. So we use these managed services and just build the pieces that differentiate us. So authentication, no, we don't build an authentication. No, we don't set up our own database. No, we don't build our own CRM. No, we don't build our own content management system. No. It's there, use it, integrate it, period. Okay, it's not that easy these days. Lambda, sometimes it really sucks, and all the other offerings from Azure and Google Cloud and so on. But it's the way to go, basically. That's in 2 or 3 years, it will work nicely. But that's how it goes. And so if you need deep logic, actually, in some places you will need that. Then you have managed containers. So no longer Kubernetes and so on. Yeah, Kubernetes is nice, but it will dissolve into behind offerings like Fargate or something like that. So containers managed in the same way as functions are managed today. Think Fargate in 3 years. That's where the schedulers will go. So you will not set that up anymore. It was here's my container, here's the condition when to trigger that, take care about the rest, I'm gone. So, and on the front end side, mobile first is just a transient trend. I mean, it's the worst user interface we ever had, so we went from 10 fingers down to 2 fingers, isn't it? So it's not possible to get any smaller. And if you're older than 50 years, most people just 1 finger left over, so slowest possible interface ever. And the shift will go away from these device-focused interfaces to human-centered interfaces. So how do we interact with the world, with the environment? We speak, we do gestures, we have haptics, tactile, and all that stuff. And this will become part of the devices, but it will also become part of the environment, so contextual environments which respond to what we are doing, change their capabilities as we are there. And augmented reality and virtual reality will blend into that in some way over time. And we will just use it. So naturally interacting with our environment as we want it and not as these stupid devices want it. big shift. And by the way, are there any user experience designers in there here? Oh, very unfortunate, because think about user experience design for a voice application. It's a little bit different than designing a mobile application and so on. And the last one is InfoSec, information security. I mean, it's indispensable. We read about all these breaches, about Internet of Shit and all that stuff. And yeah, we need it everywhere. And it must become an integral part of all stages of the IT value chain, starting when you pick up the requirements, the ideas, what you want to do. Unfortunately, right now, it's still an unloved afterthought, quite often. And we have some more trends, 4 more that I see at the moment which are relevant. The first one is artificial intelligence, which can become a real disruptor because it has the potential to do to the white-collar workers what robots did to the blue-collar workers. But still, it's quite a hype right now. So we don't know yet if we will run into the next winter of AI or not. But there's potential. It could become a real disruptor, also for us, how we do our work. Let's leave out the examples for that. But there are some very interesting examples of what works with deep learning and so on, also on the programming side right now. Just giving them pictures and they render complete HTML with CSS and so on, right from the pictures. And Internet of Things, yeah, it's getting huge. I just was on a big industry fair a few weeks ago, and all the big players are in there. And they have billions of dollars stakes in that field. So it's getting huge, and we will getting closer and closer and closer to that. Make a movement, maybe we still need the next generation of 3D printers or so on until that really lifts up. I mean, it promises to lift up and revolutionize some ideas of logistics and some other things, but yeah, we're still waiting for that. And blockchain, yeah, well, I think my personal bet is blockchain, the original promise will die this year. So the original promise, you don't need any trusted party to get business done. So which has some kind of where you want to have some trust in there. Because all the consensus and reward systems basically yield towards you have a few trusted parties in your chain. So the oldest ones like Bitcoin, 3 parties together has 51% of all transactions. You have to trust those 3 parties or you're out of blockchain, out of Bitcoin. And Ethereum, 2 parties. If you don't trust these 2 parties, better don't do Ethereum, and so on. So this kind of promise will die, but still blockchain has its value and has its place, and there will be new business models and cases and so on, but maybe with a little bit different promise in there. But we will see how it evolves. So, and now we have all that stuff. Wow. Now we're confused like hell, aren't we? I mean, a complex world, and it's not getting any better. What are you going to do with that? Tough job. And yeah, how do I figure out? So several ways to deal with that. The one I suggest right now is find a way to sort all that information in, to build a model for yourself that you can deal with, that you can see where you are and where you want to go, and then set up your plan. And that's what I'm trying to do on the next few slides. The hardest part, of course, is building that framework from that mess of information. Lots of ways to do that. I just try a simple one with 3 dimensions. What kind of work model do I want to work in? What kind of technologies do I want to pick up? And what kind of programming model do I want to work with? So developer level. If you're on the ops side, okay, you have at least to tweak the last one and figure out your own dimensions for that. Okay, let's walk through the dimensions. The work model. You remember that one? Yeah, I talked about that. Yeah, so you sort of remember that. So pre-industrial, industrial, and post-industrial. The interesting thing is you cannot only apply these concepts to markets, you can also apply that to IT. And if you apply that to IT, you get some different kind of ITs. Sorry about the missing animation. I did the mistake to use a table, and tables and PowerPoint cannot be animated properly, and I didn't want to rebuild all the stuff. Maybe I'll have to do that. But just look into that. So pre-industrial IT, basically, it's usually used in markets where it's not clear where it's leading and so on, where there's no real pressure in there. So you have no real strategic goal, what you want to do. So you have still these experts, so people who are doing everything, but it's a quite narrow area that they're covering, and low automation and ad hoc work model and so on. And mostly this do-it-yourself in programming model. Industrial, that's what we know for 30 years right now, so these process-driven software developments, ITIL, vModel, SAFe. No, SAFe is not agile, sorry about that. It's a good model for several kinds of industries, but it has nothing to do with agile. It's an industrial model, so period about that. Hierarchies, so you have these I-shaped specialists doing their part of the job and throwing over artifacts via the software development process, and so on. It's 3,000. And post-industrial, yeah, going fast, short cycle times, collaboration. That's where DevOps, Kanban, and the original agile ideas shine, basically. You have more T-shaped or this paint drip-shaped people say right now, and paradigms like cloud native and serverless and so on. Okay. And before we just can use that, one model is missing in there. And to create that, give you that one more model, we have to use a different point of view. Take this magic triangle. Fast, cheap, good. Fast. How fast can you go in IT? Cheap. How cost efficient is it? Good. How's your quality? And if you apply that, you can't optimize all three of them. It's like the CAP theorem. Whenever you optimize for two of them, the third one will be compromised in some way. And this gives you three types of governance models, basically. The first governance model is the one we know very well, so cost efficient with high quality. Okay, quite often it was neither cost efficient nor high quality. What was the result? But the original aim was cost efficiently delivering high quality. That's industrial approach. All these software development processes and so on. The post-industrial is going fast without compromising quality. And the upper edge also has, it's a startup. So we don't care about quality. We have to figure out a product market fit before our funding is dead, before our funding is gone. So there's continuous near-death experience, basically. No? Get a working product before you run out of money. That's this one. I mean, you are going to throw away 90% of your code anyway, so why care about clean code or anything, or great architecture or stuff like that, or huge scalability and whatever. You have to figure out what the customers like. Different model. It shares a lot of properties with the pre-industrial model, but it still has a very concrete and precise goal. Discover product market fit as fast as possible. And so it's a bit different internally, and it's a lot more organized, not this anything goes model. And if you think, by the way, about this pioneer, settler, and town planner metaphor, in all bigger companies, you need all three of those governance models. Unfortunately, most of the companies I know just have one IT governance model and not three of them, which makes it a little bit hard, which doesn't work very well for any of those. Well, most often it only works somehow for those, and it is complete crap for the other two ones. But anyway, so if you're unhappy, then probably these other models don't exist, and you're more like a settler or pioneer, something like that. And what I meant was you need all three of them. Usually the product evolution cycle should be, quite often, unfortunately, they start to design products, new products, most companies over here, which doesn't make a lot of sense. You should start that over there in the startup level. Figure out product that your customers like. And then, if you have a successful product, grow it. Grow your market share, grow the product. Move fast without compromising quality, because right now you need scalability, security, availability, blah, 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 blah. And then whenever market becomes slow, if the market shares are distributed and all that stuff, then go for the industrial approach. Now try to deliver the stuff as cost efficient as possible. So that's usually the cycle. By the way, I see a lot of companies who have that, and they have their startup garage. Unfortunately, they never make those two models match by any way because they're missing that one. And that's the hardest one, by the way. Okay, so let's wrap up work model. So you can use that on different level. You can use it on a different level. You can't use it on IT level. You can use it on a product or project level. And you have to figure out that for a given product, the work model will change over time. And the point for you is, what kind of model do you prefer of those ones? Where are you right now? Where do you want to be? Are you a pioneer, settler, or town planner? What do you like most? Be honest to yourself. And then you have technology. We had that one. Yeah, a few important ones. But it's too much to really make some sense out of it. So let's aggregate that a little bit. All the stuff over here is basically where we're coming from, traditional software development. Then you have this web-centered software development, a little bit different paradigm. Mobile-centered, so app development. We have the big and fast data, which is also a bit different, or actually a lot different, yeah, and including the data science guys and all that stuff. We have the cloud native area, and we have the industrial computing. Now that we're having these kinds of technology groups and paradigms, we add the trends that we've seen before. We stir that and distill major directions. You can do that in different ways. What I did is I see basically 5 possible new directions coming from traditional software development. The first one is, let's say, I want to go on the front-end side. So go from mobile-centered over time to ambient computing. So this is this side. Or you say, I stay on the back end. I accept that back end becomes commodity, but I will deliver commodity as good as possible, which usually means then that you're going towards cloud native, managed services, serverless, and all that stuff. Pick up the cloud offerings. Or, different option is say, I want to go on this smart data side. All this technology around big and fast data, the machine learning ideas, picking up AI and deep learning, because all that stuff usually needs each other. So you need a lot of data for doing training good deep learning models or machine learning models. On the other hand, all your data doesn't make a lot of sense if you don't extract any information, any value out of that. Then you can just forget about all the hard disks that you just fill up if you don't create any value from that. And that's what the deep learning and the AI stuff and all that and machine learning stuff is about. So this will blend together in some way, my bet. Smart devices, I think the maker movement will go into that, all this IoT, industrial, computing and so on, edge computing, blah, 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 all what's coming up from this side. And the last direction would be InfoSec. So across everything, how to make that stuff safe and secure. And if you take these 5 directions to go, a few last words, they're not completely separate. They're interconnected in some way. But usually, you won't be able to pick up all 5 directions at once. They are so huge, each of them, that you usually have to focus in some way. So you go one of those directions. Maybe unless you're an architect, then you have at least to understand all of directions, because you have to support your stakeholders in doing the best decisions possible. And this means that you have at least get your head around those concepts of all the 5 directions. And hopefully diving deeper into at least of one of the directions, so don't become flatline shaped. So still keep your expertise up. Okay, which of the directions do you want here? And then the last one is a programming model evolution. So we had this. Also, let's aggregate that and cluster that. Yeah, this is the random outcome domain. Then we have the local computing paradigm, where I think that most of us are in, the distributed computing paradigm, and embedded computing. And here a few words of warning, especially if you see microservices and IoT is in between somehow. The first thing is, what I see very often in the last years and also right now is that people are moving from traditional software development, so enterprise, Java enterprise, you name it and so on, towards microservices, which is a move from a local computing paradigm, so infrastructure will care about everything. I program as if I were on a single computer, on a single node, in a single process. And infrastructure will care about the rest. I make my interfaces, my session data serializable, and I'm done. But I don't have to care about all these effects of distributed computing. But if you go out into the distributed world, you have one problem. Distributed computing is, sorry, it has some effects in there. I'm missing the word right now. So it's non-deterministic. That was the word I was missing. It's non-deterministic computing, basically. So random effects happen in there. And this basically means, this non-determinism means you have to relearn computing from scratch. Everything you learned in your education and so on does not hold true anymore. If X, then Y is gone. If X, then maybe Y. And if X, then maybe, this maybe changes everything. So that's very hard. Microservices, most people I see at the moment say, yeah, I'm doing microservices. I'm actually just writing WAR files in a disguise with an embedded container, and that's it. Local computing paradigms for distributed systems, which gives you the hell of a runtime. And IoT will more and more merge the cloud paradigm with the embedded paradigm. So you have to really learn how to do those things. And now, if I put all that together, I end up in a graph like that. I could also do that three-dimensional, looks more fancy, but less readable. Okay, so we have some paradigms we know quite well. We have some paradigms we don't know that well usually. And then this is our framework, basically. And okay, now we have organized all that stuff. Now the easiest thing is, no, actually that's probably a very hard one, to figure out where you really are, because you need to be honest to yourself. And it's very hard to be honest to yourself. At least that's what I figured out for myself. I always thought I was a pioneer. I am not. And that was a really hard thing to understand for me and myself. But it made things a lot easier for me after I understood that. Where am I? What kind of programming model do I currently support and so on? And then, of course, yeah, where do I want to go? That's the easiest one. So which one do I really like? Also be really true. I mean, startup, for instance, yeah, it sounds that cool, but is it always that cool? Do I really want to work in such an environment? Some people love it, some people hate it. And better figure out if you love it or you hate it before you go that way. It's perfectly fine. And so figure out your way. Where do you want to go? Again, you need to focus in some way. And then, yeah, if you know where you are and where you want to go, find your own personal evolution plan. It's your thing. I just have a few recommendations about that. The first one is, setting up the plan is quite easy, basically. Yeah, I mean, you know where you want to go, where's literature, where's the trainings, training your skills and all that stuff. Still, based on my experience, you cannot expect your company to pay for all that. You will have to invest some of your own spare time into that. That's the sad part of the story. If you really want to change, it's a mixed game. But it's also a problem if your company does not support you at all. I mean, okay, if the company works in a complete different domain, say, yeah, I'm here in a very settled domain and I want to go the startup way, as the company says, sorry about that, we would love to support you, but here is no startup around. Yeah, it's a different story, but if there's a good way to go and you don't get any support, say, yeah, you have to do all this stuff in your spare time and no trainings and no nothing and so on, then, yeah. Love it, change it, or leave it. I see too many people sticking in the coffee kitchens and the tea kitchens, standing around and complaining whole day how crappy their job is. Hey, we're in IT. It's the best time to do whatever you want right now. So if you figure out you're standing in the coffee kitchen all time complaining how crappy everything is, reconsider your position. You're doing something wrong. Either you don't get it, what you have in here, and why you're staying then in this place. Maybe there are great things about this place, or you're at the wrong place. Be honest to yourself. Again, it's a hard thing being honest to yourself. It's probably a lot harder than being honest to somebody else. Being honest to yourself. Okay, while running out of time, a few suggestions how to stay ahead of the curve. Again, this is one way to sort that out. It's the framework I built up. The framework, it's my bets against the future. Figure out your own ideas, your own bets. Here are some general ideas how to stay ahead of the curve. The first thing I think is understand post-industrial markets. Most markets these days are post-industrial. And this consequence, speed trumps perfection. Rethink everything. Oh, reusability is key. Is it? No, it isn't. Usability is good, but it's not number one anymore. All your architects just go mad right now. No, we need reusability. No, you don't. I had lots of discussions about that. So, and understand all these ideas. Also understand where you're really doing agile and where you're doing just cargo cults. I mean, just measuring. And so when I go to a company and say, oh, we did our agile transition, I just go and say, okay, do you have big backlogs? Yeah, we have. Do you measure velocity across all projects? Okay, you're not agile. Think about that. If you have a big backlog and measure velocity, and this is your key metric, you're not agile. You do something, and it might be okay, but it's not agile. It's something different. It's a cargo cult. But we do stand-ups every day, 15 minutes, and somebody standing there makes sure it's no longer than 15 minutes. Okay, now we're definitely at cargo cult. So problem is 95% of the companies I see who claim to be agile, they're not agile. They're doing what they ever did before the last 40 years, just with a new coating, and that's it. Problem is, it's a revolution in your head. And it's really hard to pick this uncertainty thing in post-industrial markets up. I see that over and over and over again. People fall back into the habits and so on, and they always start to argue from this industrial point of view, cost efficiency and so on. It's different. Cost efficiency comes from cutting off the dead ends. It's a very different approach. But be careful how to implement that. So don't go to your CIO now and say, yeah, we have to implement all that stuff over here right now, next day. No good idea. Stepwise, please. The second thing, what I see, and that's maybe the most important one, is timeless wisdom. Good foundations of good design. Loose coupling, high cohesion, separation of concerns, and information hiding are concepts which are about 50 years old right now. And still, I hardly see anybody who really understood those concepts, what they mean, and how to apply them properly. I mean, domain-driven design leads you into the right direction. Unfortunately, at least 60% of all domain-driven design, no, it's more, it's 70 or 80% of all domain-driven designs that I've seen were not domain-driven. They were, here are my bounded contexts and my aggregates and blah, blah, blah. And here, you know, I know all the names of the cool patterns, but they didn't give me a domain-driven design. They gave me an entity-driven design. The same crap as everywhere. And the problem is you need that, because if you don't really understand how to do that, then in the past, in the local computing paradigm, you got a crappy maintainable application. So bad to change, bad to extend, and so on. But right now in our distributed world, if you get it wrong, usability, stability, acceptance on an API level gets compromised a lot, and also in runtime, robustness, availability, and scalability. And it even affects security and all that stuff. So if you get it wrong these days, it's really catastrophic. And I see very few people who really got those ideas. Read the computer science paper from the 70s to understand what it really means. And it's a little bit sad. Huh? We haven't evolved since. Yeah, Parnas, one of the people, really said that. Master of the timeless wisdom, basically. Then, become T-shaped. We're so used to becoming specialists that we should try to better generalists. We have to understand those people we collaborate with. What are these business folks are doing? What are these ops guys are doing? What are these marketing guys are talking about? Financial managers and so on. So we have to understand that. Still, you need your deep knowledge, but you have to use that in an inclusive way. That's a very different thing to do. And then for technology, yeah, either the front-end way, learn JavaScript. Sorry, no, I was one too fast. Look. Yeah, JavaScript, it's
as fast as you can learn JavaScript.
Exactly. And that's as fast as you can screw up a JavaScript program too. Yeah. Or cloud native, we talked about that a lot. Again, cloud native means understanding the offerings, the managed services offerings, also for your build pipelines. You don't set up a Jenkins pipeline anymore, you buy it. You don't set up your Elasticsearch stack, you buy it, and so on. So all this do-it-yourself and not invented here syndrome, get over it and reduce that. Here's a picture of some of the cloud offerings, and you have just to remember that behind that one are 100 more, just for instance. Or try one of the different blends, like smart data, be prepared to refresh your math, or smart devices. Hey, a wild open field at the moment, lots of exciting challenges if you like it and want to refresh your C programming right now. But it's a lot of fun, actually, if you like C programming. Okay, the Rust compilers will come in a while, but it takes a little bit. Or InfoSec, everywhere needed. Hard topic, by the way. And the last thing, the last recommendation I have is embrace distributed systems. Basically everything we're doing these days in enterprise systems, all systems are distributed in some way. They're talking to other systems online in real time. And you have to understand the non-deterministic behaviors. That's what I see in almost every project, not only when I'm going to talk about resilient software design, but in all types of design and implementation and so on. So non-deterministic behavior, again, changes everything, how we design systems, even how we design interfaces, how we interact, and so on. And good starting points for that is the ideas of memory guesses and topologies that Pat Helland coined in his seminal paper, Building on Quicksand, which was released in 2009, or the premise theory from Burgess, which gives a complete mathematical foundation on that, which says, yeah, most of the time it goes right, but sometimes it goes wrong, and better be prepared for when it's going wrong and not say, yeah, it will go right. And so an understanding that your infrastructure will not guarantee and keep the things running as you always thought the years before. Okay. Hey, I'm over time. What a surprise. Sorry about that. Do we need to talk about that a lot? No, I don't think so. Huh? I mean, the wrap-up is, basically we're running from industrial to post-industrial, and we have new trends, which gives us also new options, but also new things to ponder, basically. And our programming model is distributed these days. We have to deal with that. Maybe the most important things to learn is that generalists, T-shapedness and empathy becomes crucial these days, and the timeless wisdom we have to rediscover, basically. Figure out where you are and where you want to be. Influence the game or try a different game. And it's a Hitchhiker's Guide. If I confused you a little bit too much at the moment, first of all, sorry about that. Don't be confused. My intention wasn't to scare the hell out of you or anything like that. One thing you have to understand is I'm the CTO of a company who claims to be knowledge leader, which means I'm more like the ghost of the Christmas yet to come, but hopefully not that scary, basically. So always being with my head 2 or 5 years ahead. So it's a lot of time. It's a lot of time probably for many companies until you get there. But if you figure out right now what's going to come, if you have these ideas, oh, there are some ideas that are maybe worth pondering, then you have enough time to figure out where you want to go, what you want to do, where you want to head to, and so on. And again, it's my perception of the market. It's my bet against the future based on my experiences. Your experiences, your bets may be different, and that's perfectly fine. Take your experiences, take your bets against the future of the market, and build your own model and figure out the way. The only thing important is keep moving. Be honest to yourself, figure out where you are, figure out where you want to go, and change the game. Thanks for your time, your patience, and